Hello, welcome to more of me learning Haskell and streaming it. Plan for today is do more Advent of Code to do day 8, which is the next day available. Hopefully it'll go well if it's not too tricky. If I get through it in plenty of time, in good time, I might have a look back at some of the stuff I picked up from day 4, particularly because I used control arrow, which is quite exciting. But it might be a tricky one. It might take me the full hour or more than an hour. We'll see how it goes. Yeah, it's a bit chilly today, so I'm drinking a very nice but strong whiskey. So it'll be interesting to see if that has an effect on me throughout the episode. But it'll probably be fine. We'll see. Okay, let's take a look at day 8. Actually, I brought up day 8, but before I jump into the problem for today, I just want to set up the project, I guess, so I can, not the project, but the executable. I've been following the same pattern for all the days I've been doing. Oops. Maybe that's the center. So day 8, import share properties. The directory is going to be called day 8. It'll have a main and it'll have part 1. We don't need containers yet. And then I'm just going to create these as a little bit of boring typing. I should probably have done this in advance actually, because it's probably not that interesting to watch, but this is how I'm setting up a project. So in day 8, I'll create a main.hs, and this will be module main, export main, where, and then for the main function, I'm just saying main as a type IO. And the definition of main has always been interact. It might change a bit if the file gets trickier, but interact and then solve parts. Just write solve parts. And that's of type string to string. So the input string is whatever it reads in from standard in. This is what interact is doing. We'll produce some result, which is a string, and then interact will print it out for me. And for now, solve parts is going to be, well, it'll be passed an s, which is some string. We will call part1.solve, which I need to go and write, passing s into that, and then we'll just add a new line onto the end. So we'll also need a file called part1. And this will be, oh, it had it there for me, module part1. We'll export a single function from here called solve. And then solve is again of type string to string. So it gets given the input from standard in. And for now, to say solve is equal to ID. So we'll just print out whatever you feed it in. It's just a placeholder. I've been finding it makes sense to split it into 2 files, one for part 1, one for part 2, because quite often part 2 would take some of the work from part 1 and modify it. So it's helpful to keep them separate. Okay, not the most exciting thing, but it gets us set up. So now I can go and read day 8. Let's make it bigger. Treetop tree house. Okay, so we come across a patch of trees all planted carefully in a grid. Oh no. I said it now, I remember these from last year, these kind of matrix style layouts. Can be a little bit tricky in Haskell, but I'll see if my Haskell's improved enough to deal with them properly. I'll explain the previous description planted these trees. Okay, I say it's a good location for a tree house. And they want to know there's enough tree cover to keep a tree house hidden. So you need to count the number of trees are visible from outside the grid when looking along a row or a column. Okay, so they have a quadcopter generate a map with the height of each tree. Okay, so let's do that. Copy that. I'm just going to go into my project, create a new file in here called test input, and just paste that in there. Okay, single digit, which is the height from 0 to 9. A tree is visible if all the other trees between it and the edge are shorter. Okay, so 512 would be visible. It wouldn't be visible from this side. Only consider trees in the same row or column. Okay. So no diagonals, nice. All of the trees on the edge are visible, of course, yep. Okay, so we drop out the outer ones and then we're left with these three and these three and these three. We need to find something which is blocked from view, which would be the one in the center here. So top left 5 is visible. Top middle 5 is visible from top and right. Yeah. Okay, that makes sense. With 16 trees visible on the edge and another 5 visible, 21 are visible. Okay, consider how many trees are visible from outside the grid. Okay. How many trees are visible? So it'll be the count of, the width times 2 and the height times 2, which is the outer grid. And then we need to start looking inside. So it's a little bit annoying because from a single tree, we'll need to be able to go up and across. This is stuff I found a bit tricky last year to do in Haskell. So we'll see if it's any better. I'll just check that things are working. So I should be able to say Cabal run day 8, and pipe in day 8 test input. And let's just print it out again. This is just to check the plumbing works. Nope. This plumbing does not work because in main I haven't imported this. So I'll just tell it to import it. And then run it again. And there we go. Okay, just prints the grid out again. Okay. So I guess I'll just pull this into a list of lists to start with. Let's do that because I'll probably need that. So we're going to take a string. Oops, sorry. We're going to take a list of strings and we are going to return a list of ints because a string is already a list of characters. So parse, I forgot to get a chat up actually. Let me bring chat up for a second so I can go in here and go to there. Just in case anyone's online and watching, be nice to see. Oh, people are here. Tim and Will are here. Hello. Let me just pop that out. Then I can get rid of that tab. And I've lost the chat now already. Just move over here. Hi and welcome. Okay. Back to the code. You can shout out fixes as we go. So if we have an empty list, so we've run out of input, that's nice and easy. We just spit out an empty line. And if we have some lines, like a row, let's call this a row, and we have the rest of the rows, then it's going to be, we're going to map read over the row. That will give us a list of ints. And then we want to append that onto, so I'll just bracket this whole thing. So we're going to map read over the row. That should give us a list of ints, and we'll stick that onto our output, which is going to be is that going to work? Let's see. Parsing the rest. So we can actually make this a list of events, I think. No, that can just be an empty list. That should be okay, actually. Okay, so let's start with the various warnings. So what's it saying? Apply hint, use map, redundant bracket, use map in this module. I'm using map, what? I got about where we're in this map read rest. Okay, let's do that. I guess that makes sense. Map. It wouldn't be rest in that case, it would just be map map read, wouldn't it? Except it can't read because it couldn't much type list of characters with character. Oh, good point. We can't read a character into an int. We can't use read on a character, we can only use read on a string. So I just write something called to int. So where to int, this is going to go from a character to an int, and then to int, I can call ordinal on the input. So let's call this C. And then I need to know what the ASCII code for 1 is, and then basically subtract, or maybe 0 is, and subtract that. Which I don't know. So let's say, typo there, GHCI, try again. Is ordinal in scope? No. Import data char. The ordinal of this, the character, again, the character 1 is 49, so 0 will be 48, obviously. So I'll just subtract 48 from this answer. So that minus 48, and then import this. So now I should have something which returns a list of integers. Okay, 30373, just check this is right. So 30373 and 255 and then whatever else. Okay, cool. Right, so now we need to walk through it and look and see if there's stuff outside of it, which is, in this case, because we want visible trees, we just need to make sure everything is smaller. So what I might do is say, I might split this into 4 functions. So we'll look up, down, left, and right. So we're going to take a position, which is going to be a pair of ints. And they're easy to remember in hex. So 0x30, 0x31. Okay. I see, I'll forget that because it's not that easy to remember that the hex for 0 was 30. Because I need to remember it's, like, how would I remember it is 30 and not 40 or 50 or whatever else? I don't know if that's easier to remember than 48. But I might be wrong. Anyway, so we're going to take a position. We are going to take a list of strings. List of ints, sorry. List of ints. So this is our full grid. And we're going to return a bool from that. So smaller up, where we're looking at the first element, and then we don't care what the second element is. So we're looking at the first row basically, or maybe it's the first column actually, because it'll be x and y coordinates. Then we don't really care what the input list is because we know, we know that this is going to be true because it's on the outside. Smaller up, next one is easy, so we can go whatever in 0 and then we don't care what the actual input is, because this is also true because we're by definition on the outside. So now it gets a bit more interesting. So smaller up of x and y of some grid G. And I'll say a couple of guards here. So if x is equal to the length of G, no, head of G. So the head of G will give me a row. If x is equal to the length of the row, we'll fall outside the grid. So it should be this minus 1, this minus 1. Then I think we're an edge piece. Where's it equals gone? Equals true. If y is equal to the length of G, the length of G minus 1, not plus 1, minus 1, that's also equal to true. So this is the other outer edge. And then we have to do some work after that. So otherwise, and then we want to, this is only looking up. Oh. Actually, because we're only looking up, this is irrelevant. I might make this smaller. And in fact, I might just rename it as visible, because I seem to be solving them all in one go. Okay, otherwise, what are we going to do? We're going to check up, then we're going to check down, then we're going to check left and right. So, actually, yeah, we need to do that. Okay, so we need to go check up, and we'll pass in, the only thing we care about is the y coordinate here, and G. So check up, given some, I'll give it a type here. It's going to go from int to list of ints to bool. So this is the y coordinate. So checking up, given the y in the grid, what I want to do is select, checking up should be given x, for goodness sake. So I need the x coordinates, so maybe I want to say, we're going to need both actually. We're going to need to know where position 3, like the second element in, and we need to know that we're the second element down, because then we're going to pick out the second element across from these two rows. So we're basically going to slice rows from 0 up to whatever this y index is, and then we're going to pull out the second element of both. Check that. So it'll need both the x and y. So again, this is going to be int and int. So here we will destructure again to x and y. I'm going to make this its own function. which is probably what I intended to do originally, and I got sidetracked checking all conditions. So given x, y, and g, so the first thing I said we need to do is pull out the rows from 0 to y. So we can say take y from g. Okay, and that will give us a list of rows. And then what we want to do is we want to map bang bang x over it. Over that. And then that should give us a list of integers. So if this is correct, we should end up with, if we're starting here, we should end up with 3, 5. That's my plan. And then the next thing we do is pull out the element that we're checking. So this is going to be g bang bang y. Let's write this whole thing. Bang bang x. And then we want to say this should be less than result of this. Oh, I don't need that. Okay. I can do this, maybe. Okay, that's what I'm hoping. So, oh, no, it needs to be smaller than everything inside there. So we need to say something like, and less than that over that. Is that how it works? What's this problem now? So and will take something foldable, which should be the result of our map. Oh, we need to bracket this. Okay, so mapping this should give us, we should end up here with a list of ints. And we'll take foldable t, so it's going to be okay, right. So I need to turn it into a list of bools, and then we just and it together. So what I really need to do is map this over this. This is horribly unreadable. What's it saying? Okay, I can use all instead of and map. Let's do that one instead. So I can get rid of this map. And now it's saying redundant map. Show me your suggestion. Why not replace the map with this? Oh, that's so hard to read though. Is that not what I'm suggesting? I wish it would auto apply these hints for me, but I need to fix my environment for that. So it's less than g blah, 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 dot those things. Oh, I need an extra bracket here. Okay. And then I get rid of this one. That's tricky. Okay. What I might do is just export check up. And then it might just work. I could just run it and see, but I'm a little bit dubious of that. This doesn't look like the kind of function I would write correctly first time. Check down X and Y and G. So check down. So it's slightly different in that we don't take Y from G, we drop Y plus 1 from G. People watching along, does this make any sense at all? It just looks like a line of symbols to me, a little bit. Check left, X and Y and G. Oops. Well, come on, John. Copy and paste. Right, check left. Slightly different behavior. So, check left, what we want to do is simply get the current row back. So that'll be just bang bang actually to get that back. And then we drop checking left is just we take X out of that. So we're going to start off with this is just going to be G bang bang Y. So that's going to give us a list of integers back. And it's a single line now. Let's get rid of all this. So we got a single row, and then from that single row, we want to take X from that, and that should give us a list of integers. And now I want to say all less than, I'm just going to write help for this. I'm going to say at, we'll give it a position, so int and int, and just return the value there. So we can say at X and Y, and this is my G bang bang Y bang bang X. Oh, it needs the grid as well. I hope these are left associative. They probably are. So I'm going to just give this a name. I'll call it P for position. This doesn't make sense, but we're going to say all less than at PG from that. And bracket this. So with this one, I can say at PG, if I just capture P, we'll do the same thing here. Okay, and then take right, oh sorry, check right. Similar thing, but we don't take x from a row, we drop x plus 1. From that. Okay. So here we should be able to say and check right. X, Y, and G. I think so. Okay, now we need to make a list of coordinates. Oops. And this is going to go from a list of int, so just a list of int, so the grid basically, and it'll give us back all of the possible coordinates in there. So we'll get a list of int. So given the grid G, we want zip. And what we're going to do, we're going to do the first list, which goes from, oops, it goes from 0 up to the maximum x, which is the length of the first element of y, or the first element of G. So the first row, basically. What's the length of the first row? So it's G bang 0. And it's going to be, oh, don't do that. It's going to be -1, and these brackets are wrong. It should be these brackets, I think. Halfway there, and we zip it with the same thing again, but this time it's just from 0 up to the length of G -1. Okay, this time I don't need some brackets in places. It's going to suggest first, presumably, or head. Yep. Head of G. And this is going to be the length of G -1. Okay, so we have our coordinates, and then we have whether or not they're visible. And it's just a number of things which are visible. So we've parsed our stuff into a list of into the grid, basically. I might just break this up a bit. So it's our input string. We can say where grid is equal to this. Parse, oops. Should be right. Actually, we don't need to pass in thing. So we can shoot a grid for sure, but that's not quite going to do. This can no longer be point free because we've got the variable. Okay, so now that we have the grids, we can take the coordinates of this, and this will give us a list of pairs, and then we can map visible, oh damn it, of the grid of S. let me not pass this in. Let me just call it grid. Visible grid over the coordinates there. So grid, we can just say this is parse lines S. Right, I have my arguments running around in visible. I want to swap them, so we pass in the grid first. And then we get rid of this one. Then we just flip these. And G goes there, and then it should be good. Yep. Okay, so doing this should give us a list of bools, I believe. Well, let's see. Gives us a list of bools, but it's much shorter than I expected it to be. It's only done it for one row by the looks of it. One thing, I'm not quite sure what this is giving us back actually. Let's see what coordinates gives us back. Now it's going to complain because I'm not using visible, so let's temporarily export it just to shut the compiler up. Try running it again. Okay, now it gives us back this. That's not enough though. Okay. What's the function I'm looking for? That given a list of A's and a list of B's gives us, is it permutations? Does it give us all the permutations? Is that what it is? Not quite. So we've got a list of A's and a list of B's. They have the A's again. And we want a list of A-B pairs, but we don't want zip. Mesh, torus, probably not things we want. They're also in extra packages. Okay, generating coordinates is harder than I expected. Internet, that did give us an answer. I just want to see the answer is correct. So it's given me the diagonal through the grid, and we think the answer to this is somewhere. I've lost it now. I've lost my true false output. That's gone. Okay, that's annoying. Okay, coordinates. So from I want a list of things. So I think I actually want to repeat this. Not repeat, cycle this. No, not quite. I want to start with 0 and then go from 0, 0 to 0, whatever. So I think what I can do is I can say map and I'll give it a function. It's horrible. So text, actually it's going to be y. it takes the y argument and it's going to zip this with the repetition of y. Avoid lambda. It's something stupid like dot repeat. And then you drop the y off. Is that what its suggestion is? Oops. It is indeed dot repeat and you drop the y off. Okay. Now, I need to drop the y. Okay, what's this problem? Couldn't match type list of intent with intent. Okay, what's repeat y give me? Repeat y should just give me a list of oh, I want to flatten it. There's like concat map. It is just like concat map. Okay, so I was getting, because I was mapping over, I was getting the first thing being the first row, and then the second element being another list of the second row. But I can just flatten this out. So in theory, if I run it now, if I've saved it, that's better. Okay, it's not quite what I meant to do, but it's fine. So that should have every coordinate in it. So now we can put our visible back in again. So it was map visible grid of that. And I can just stop exporting it because I don't need to shut the compiler up anymore because I'm using it. And it gives us some answers. Okay. And it's completely wrong. So, or is it completely wrong? Sorry, no, this is, they want to count of visible things. So I can say, not all, but can I say filter equals true from this? Gives us those things, let me just count them, I guess. Oops. And it says there are 16, and this says there are 16. No, 21 are visible. Okay. So something's gone wrong. To be visible, you don't need to be visible from all directions. You need to be visible from one direction, not the band. So you need to be visible up, down, left, or right. 21. And the correct answer here is 21. Okay, let's get the puzzle input. Create a new file called input. Good. And run it with input. And it reckons it's 1,870. See if it's correct. Oh, it is correct. That's the correct answer. Hooray. Okay, cool. Part 2. they need to know the best spot. So the views from a given tree, look up, down, left, or right from that tree. Stop if you reach an edge or the first tree that's the same height or taller. Same height or taller. Okay. This has got 0. That will have 1. Consider the middle 5 and second row. Okay, yeah. So looking up, you can see 1 that's not blocked. Looking left, something the same size. Okay, looking right, it should be 2. Yep, and then looking down, 2. Yeah. And then you multiply these together. And then the highest scenic score. Okay, so they're not looking for something hidden, they're looking for something with a good view. Okay, part 2. Part 2.hs. Module, part 2. We'll export solve again. Where solve goes from string to string. Solve equals. I'm just going to print something out. Save part 2. Go back to the cabal file, and we want part 2, but we'll also want pars. I'm going to pull out some common stuff into a module called pars. Par.hs. That should do for now, and then we go back to main. And we'll just print out part2.solve and then another blank line. What did I do for part 2? Part2.solve string to string. Oh, I'm not passing an S, that's what's wrong. Okay, so if I run it with test input, it should say part 2. Good. Okay, back to part 1, all the parsing stuff. I might pull out parsing and coordinates, I guess. I think they're going to be in common. So we can export pars and we'll export coordinates. Expand data.char.ord. Okay, and then back to part 1, and we'll just delete those, and then re-import them from here. And then do that. Okay, and then, oops, make sure it still compiles. Yeah, we're all good. Okay, let's grab this solve and we'll jump into, in fact, I'm just going to grab the contents of this file, because we'll probably want most of it, but just doctored slightly. Okay, so we'll pull in coordinates again. And we will pull in pars again. What I'm going to do here, so we want the distance up, distance down, which is a little bit more involved. We need to walk through it rather than just taking the whole row. So what I'm going to do is write the thing called distance up, it's going to take the position, it's going to take, in this case, just a list of ints, and that's going to be just the values at the same, in the same column, but going up from it. So we'll pass in, if we're looking at this middle 3, for example, we'll pass in 3 and 5. And it's going to return a score. So distance up, doesn't matter what you got. We are going to, if there's nothing above you, nothing left to look at, then this is just going to be 0. Whereas distance up of x and y, no, we can just capture it as p, actually. We're going to pass in the value. So this is going to be the value, the height of the tree at a particular point, and then the stuff up from it. Okay, so otherwise, if we have some value, some height, and we have some tree and the rest, one of two things. So if the tree you're looking at is greater or equal, so let's flip it around. If the tree we're looking at is smaller than the tree, if the tree we're starting at is smaller than the tree we're looking at, yeah, I need to be a bit careful here. So I need to flip this. So we'll pull out 3 and 5, then we'll flip it so it becomes 5 and 3, so that we compare. Oh no, yeah, we'll compare 3 to 5 first, and only then will we consider comparing 3 to 3 if we get past 5, which we don't in this case. So, okay, we look at the first tree. If it is bigger than us, then we need to stop. So there is no more, no more distance available. Otherwise, we are at least as big as t. Oh, we stop. Sorry, we stop at the same height, don't we? Okay, so the tree we're looking at, around, tree we're looking at is smaller than the height of the current tree, the tree we're interested in. Then what do? We do 1 plus, and then the distance up from the tree we're interested in, the height of that tree, and the rest of the trees in that row. Otherwise, the other tree is at least as tall as us, so we stop. Okay. What do they call this? The scenic score. Scenic score. Let's call it scenic. And you multiply them together. Okay. So the scenic score for a particular element. Oops. So given we have some x and y. we'll give it an int. Actually, this is probably going to be the wrong way around. We'll start with the grid. Give them some grid. And some position. Just 1 second. There's an extra heater on because it was cold earlier, but it's actually warm again. So we start with the grid and a particular position, and we want to return some score. So we start with the grid, we've got a position, and we're going to say it's the distance up. I think it's called you multiply them together. Is that right? 8. Okay, so if you're on the edge, the sync score is always going to be 0. Okay. So we look at distance up, and then we need to give it at PG, so that's the position, and then we need to give it the column, the reversed column. Where the column from this is going to be column up, I think, actually. The column up I guess we'll give it a pair of ints, even though we only need one of them. And a grid, which is a list of ints. So call up X and Y and G. It's one of these nonsenses. So it's, you want to, I think this is where you do bang bang X. Oops. Bang bang X over, so it'll be a map, bang bang X over take Y of G. Ints is going to return list of ints. That should say P. So that, okay. Showing the binding, and actually G will be the same throughout, so we need to pass it in. So we can get rid of that. And then we can get rid of it here. And we can get rid of it here. But we'll leave it now. Okay. So that's going to be a distance up. So we're passing it in the value at point P, which is the height, and we're passing it in the column going up from it. So we're selecting these values, but then we reverse them. So we start looking at 5 first and then 3. So we're looking out. Okay. And then I might use some names. So let's go up. That was down. And we can say up is equal to that. Down is distance down. And actually we don't need distance up, distance down. we just need distance and we feed it in different lists. And then we can get this. I'm going to leave it in place in case I need to look at them. Up is done, I think. So now down. So this is going to be call down of P. And we don't need to pass P in because we have P available. In fact, we could just destructure this point, so we could say nope, P at XY. And then this call up is just a list of ints. Okay. Column down we don't reverse. The column up I might just move the reverse into here. Okay, and column down, it's not really worth putting the type signature in place this time. So this is going to be, we still map bang bang x, but this time it's over drop, and then it's y plus 1 g. And then times left and right. So left is distance at PG, call left, and right is the distance at PG of call right. So call left. So what we're going to do, we'll start with G bang bang Y. So that's the row. And to go left, this is just take X from that. And call right is drop X plus 1 of G bang bang Y. Then we get rid of all of these except that. So they're using, we'll put into pars, make that common. Okay. So now we work out a scenic score. Right. So what do we start with? We want to work out the scenic score for every coordinate. And then we can just say show it. Let's see what it comes out with. It's not looking good. Okay, I'm not quite sure what I've done now. Because there's stuff that's better than 2. In fact, we should be 8. Okay, something wrong with one of these. So taking left, we actually want to reverse this. Turns out it'll make a big difference or not, but that was definitely a mistake. It's made it worse. Oh my goodness. Okay, let's walk through this. So let me I think you can see one tree bigger than you but are counting 0. Oh, am I? Okay. So if we start, let's look at the example. So 5 in the middle row. Looking up, it's not blocked, so it's a distance of 1. Looking left, it is blocked. Oh, so I can see 1 tree. Oh, I see. And looking the other way, it's got 2 trees. Right, okay, so I'm multiplying by 0 a lot of the time, I guess, and just cancelling out anything. So it's only 0 on the edges. Is that right? If it's on the edge, its view distance will be 0. Okay, so I think this should be 1. Yeah, okay, that looks good. So we have more sensible heights. And yeah, stuff along the edges is being zeroed. Okay, and 8 is the maximum from that, I guess. So what we actually want to show is the maximum from that. Should be 8. And that's what they say, right? This is the ideal spot. Okay. And then they're saying, what is the highest index score possible for any tree? Apparently it's this. 517,440. I wonder if this is right. I don't have much confidence. Oh, but it is correct. Hooray! There we go. Done it. Thanks for your help, Tim. It would have taken me ages to notice that I was using 0 rather than 1, which is cancelling everything out. Cool. So I just commit this, I guess. This is admin of code, day 8. And push upstream. Cool. Well, thank you for watching along. Finished it in almost the correct amount of time. Yeah, hopefully you can join me next week. And yeah, thank you again for watching. Yep, see you. Goodbye.